Hi everyone. In this session, we will be modeling the advanced model. We will be modeling a 2D cell with multiple layers as the anode function layer. So as you can see, we will be having multi-layer cell with electrolyte and the interlayer at the center, the anode function layer, anode support layer, cathode functional layer, and cathode current collecting layer. So these will make up the cell geometry, and the thicknesses that we will be modeling, these are from this article which is referenced, but we will be making a 2D model for a better analysis or a more detailed picture for the thermal gradients and potentials, electric potentials. So for this we will need to start with the basic geometry, and the first part of our so we'll be modeling in three different environments. uh, the first part is to make it in the first part we'll make it in the workbench itself using the Spaceclaim. So we can directly go to mesh and start the geometry by clicking on new Spaceclaim geometry. In this environment now we will look into the modeling. So for starting it, we will have the y-axis as along the height of the cell, and starting from the origin we will have the from the xz plane. From the origin we'll start our rectangular geometry of the cell. So the first is the on top we will do model the cathode because it is very thin, and below in the negative y direction we will model the anode side. Like previously, we can model everything in this orientation, and so that we can just draw the rectangles and extrude them. So that is the most convenient part, to draw all the layers of the cell. And apart from the cell, then we will be modeling the manifold and the interconnect. But before starting further, since the cell geometries are in micrometers, so we should change the units to micrometers, use tight tolerances, and the divisions that we should have is 1 micrometer. Okay. Okay, now we are already in xy plane, so we don't want the xy plane, so yeah, no, sorry, we need the xy plane, and z is in, we are looking at the positive z direction, and we are in the xy plane. So now either we can model the rectangles in xz plane and extrude it in y direction, or we can model them in xy plane and extrude along the z direction. So the most easiest way is to draw the rectangular sections in the xy plane, which we will do right now. Start from the origin, and so on the top side is the cathode. So the cathode is the length of the cathode is the span is 19,000 by only 10 mm, 10 microns. It's very thin. As you can see, it's very thin compared to the length, and on top of it is the CCCL. That's again, again 10 micron thick only. Now we have two rectangles. The first is the cathode function layer, and on top of it is the cathode current collecting layer. Now on the anode side we have the anode function layer and the anode support layer. The anode function layer is only 7 micron thick as given in the literature, so we will draw it for 7 micron. it went to opposite, so we should undo it. Oh, that also got erased. So draw the rectangle again, and this is 10 micron anode functional layer. Now this is 7 and this is 19,000. The next is the anode support layer, and the anode support layer is 1 mm thick, so that is 1000 micron. Yes. Now we have drawn the cathode side and the anode side. Since they will have different properties, the functional layer and the support layer, and here also there's a functional layer and the current collecting layer, so we need to have different geometric entities. Now there is mesh also included, and the mesh thicknesses given are 300 micron and 500 micron, with 500 micron at the anode side. So you'll have 300 micron, 1000. Likewise over here we have 500 micron. So these are all the layers that are needed for the cell, including the mesh, cobalt nickel mesh and the nickel mesh. And now we will extrude each layer from the bottom, starting from the bottom. This is 19,000 again. Oh, one important step before we can extrude this, there should be no merge option enabled. So now when we extrude it, it will treat it as a separate body. Anode functional layer, make sure that the no merge option is on. Now there's no solid surface, these are all solids, no surfaces left. We can rename them over here for our easiness, or we can rename in the mesh, but to make the other components it's better that we make new components over here. So we can go to the design and add new component, and this new component we want to make the interconnects and the manifold separately. So first part we will make the interconnects. One interconnect will be on the top and one at the bottom, but they will be in different orientations. So since we want that the hydrogen should flow in the x direction and hydrogen is on the anode side, so the interconnect will be extruded in the positive x direction at the anode side. On the cathode side, on the top, it will be extruded in the positive z direction. So we can sketch. We will first make the top side, and on the top side, that this is the cathode, so we should do the extrusion on the positive z direction. Now we can have the sketch view. Yes, and the interconnect, the end of the cell is actually engaged directly with the gas, so there's no interconnect body on the ends of the cell. We'll make a line starting from the end, that's 1000 mm, and then we should make a rectangle 1000 by 1000. You can end the sketch and extrude this again to 19,000 micron, and we can this body we can eh, have a linear pattern of it. You see, these will be the interconnect where the cell have the interconnect touching the cell, and in between will be the manifold channels. So we can have it okay, and again sketch mode, and we can have a construction line starting from here. The interconnect height doesn't matter much, so we will draw it a minimal length, that is 500, and the opposite side again full length must be covered. And this we can have it to extrude it to, and to make it a full body we can create them, combine them. Let's select this solid body and combine, add. Now see, all of them are added to it, and we can delete the construction lines. Okay, now we have made the interconnect at the cathode side. Now we want to make the manifold that fills in all the gas channels, and also model the inlet and outlet of the at the cathode side of the channels. In order to do that, you can hide all other bodies for solid, hide others, and we can have a new component that will be the manifold for cathode side. New component, or you can call it gas channel. Gas channel cathode. Okay, for making the gas channel we should sketch in this plane. Go to the sketch plane and let's project these surfaces, project lines. We can 1000 1000, sorry, and we can add the arcs. Add another arc. Why is it like this? We can have a 3-point arc. Since the gas channel gives some space for the tightening of nuts and bolts, so it expands actually. So there is actually less flow coming to the corner channels. In order to simulate it properly, we model it like this, and we can have an orientation where we can have a plane. So we can have a construction line. Since this is 19,000, so we can go to the center. That will be 9,500, and have a line like this, and this is already at the center. I think we can have a dimension from here till that is 9,500 micron. So these are the we have a construction line, and we can actually, using this line, we can mirror it. And then again, using the mirror, we can delete this, and we can add a soldered line, and also add soldered lines. Now this is the open channel, we can also project the line. We need to delete this first, and here also. Now we can finish the editing, and this surface can be extruded now. Control Z. We need to extrude it only 1000 micron, and this will make our gas channel complete. So you can see now the gas channel at the cathode side is complete, including the interconnect. Now the interconnect sits exactly in within the gas channel. Now display all, show all. So now we have displayed all of the components. Now in the similar manner, we should make the one at the bottom for the anode side, but that will be needed to be extruded in the x direction. So for the cathode side, the inlet is actually in the pole in the z direction, inlet and outlet, but for the hydrogen, inlet is in the x direction, so we will make it in this direction. And the first part, we will again make the interconnect first and then make the manifold. So we'll add a new component, interconnect. You can call it interconnect anode. Right now naming doesn't matter much. This naming will be most important when we make when we do the meshing. But in the interconnect, again, we need to leave space for the gas channel. That will be 1000 micron, and then starting from here we will draw the interconnect rectangle. This is correct. And again we will have the sketch mode on, and using this we will draw the rectangle. $500 by 19,000. And okay, you can extrude this surface by 19,000. Now if we want to make this solid surface combine, now as you can see we have again the interconnect model for the anode side, and we have space available for the gas channel at the corners. So we will uncheck all, we will check the visibility except for the interconnect, and now on the top plane we will draw the manifold, get the gas channels. You can close them now. And likewise we can add the arcs. We can have a construction line. Okay, and sorry we can this is mirror, and we can mirror it in this direction, and then we can mirror again in this direction. Just add a line to it. And we would like to actually extrude this surface by 1000 micron. Oh, sorry, we didn't make the manifold separately. Okay, at least we should make it no merge. Now we made this surface, and with the no merge option we can actually extrude it to 1000 micron, and we'll have two other solids. This is the interconnect and this is the manifold. We can name it interconnect anode, and this one as a gas channel anode. Huh? So this is the interconnect at the cathode side. Okay. Now this concludes our model for at the Spaceclaim. Now we can save this geometry, save it as, we can call it our advanced model or design one, that's also okay. And in the Spaceclaim in the our working directory, save it, and with saving it we can again open it in any workbench directory. For now we can just close it and update the mesh icon and edit the mesh, and we will get this geometry into the meshing environment. As you can see, we got all the solids into our meshing environment, and we can here we will discuss the meshing later. Thank you. And now we can save it. This will save our workbench. So in the workbench we can save as into the working directory, the reacting and in the simulation, sorry, we will make it in the geometry. We can save over here, design, cell design 1. We will continue with the meshing, and we can close the mesh and continue with the meshing later on. Thank you.